Hey, good morning. Uh, so we will start in 4 minutes. Let's wait for a little bit while. Hi. Yeah, good morning all. I just want to make sure if you can hear me, could you please type one? Yeah, just one of you type one will be great. Oh, thanks. Thank you very much. Oh, cool. That's cool. Okay, so let's start. Yeah, so we have tried to collect some of your questions during the weekend, but then, yeah, because I think we are at the beginning of this course, so you don't have much questions. So instead, so I've prepared something for you. Hope that you will find them interesting. So okay, so we have started with the definition of a proposition. So a proposition is a declarative sentence that is either true or false, but then we cannot take both. So it can't be both true and false, and it also can't be neither true nor false. Okay. So there are two very easy examples. So one is like Kai likes apples, and then the other one is Kai doesn't like pizzas. So we don't know whether each of these sentences is true or false, but then we know that it can only be either true or false, but not both. Okay. So either I like apples or I do not like apple. So one of them is the only choice. But let's take a look of the next one. Okay, so suppose that you see on a certain wooden board and there is a sentence written on it. So it says the sentence is false. Now, it looks like it, so first of all, it looks like it is a sentence, right? So it is a sentence. And then it is a declarative sentence, right? So it is declaring that this particular sentence itself is false. But let's take a look whether this can be a proposition or not. So if you want to make it a proposition, so let's check whether this can be a true proposition. Now, if this is a true proposition, the whole thing is a true proposition, that means that what is written on it is true. So what is written on it means the sentence written on it is true, but on the other hand, what it is actually written is the sentence is false. So we will see that there is something wrong here. There is a kind of we will call it a contradiction going on here. So in conclusion, we will find that this sentence cannot be a true proposition. Is that okay? Now, let's take a look at the other option. So could this be a false proposition? Now, if this is a false proposition, then what does that mean? It means that what it is written is false. So what it is written is the sentence is false will be false. So what do we have? So wow, I'm getting stuck. So let's go back again. So it's a little bit confusing. So let's double check again. So let's start from we are trying to find out whether this proposition could be a false. So we are trying to find out whether this sentence could be a false proposition. Now, if this sentence is a false proposition, then what does that mean? Then it means that this sentence is false will be a correct description of what is going on. But now we will see that it actually writes the sentence is false, which makes it a true claim. So when we assume that what is written is false, then we will get the conclusion that what is written is correct. So what is written is false, what is written is wrong, will imply that what is written is correct. So that means that we will also get something wrong. So in the end, we can conclude that this sentence, although it looks like a declarative sentence, but it is not a proposition because it cannot be a true proposition and it cannot be a false proposition. So by definition, so this is the definition of a proposition, we need this sentence to be either true or false. But then what we have here is it cannot be true and it cannot be false. So it is not a proposition. Is that okay? So this is something that is very, very, confusing. But if you are okay, let me see. If you are not okay, could you please type a 2 here? So let me see if you are not okay. Eh? So everyone is okay. Cool. Okay. Now let's take a look of the next one. Okay. Now I just change it a little bit. Look at it. So there is a change here. Now this time, what I'm writing on it is this sentence is true. So this is a declarative sentence, but we want to check whether this is a proposition or not. So what do you think? If you think this is a proposition, could you please type, let's say, type a 3. If you think this is a proposition, type 3. If you think it is not a proposition, could you please type 4? So proposition 3, not proposition 4. Okay, so I have seen that. So most of you, It gives me 3 as the answer. Okay, so let me see. But then I would say that this is not a proposition. Okay, so it should be 4. What is the reason? Okay, so there are two reasons that we can see. So first of all, we have discussed how we can make a proposition into another one by using logical operators, right? So we have talked about negation, we have talked about and, we have talked about or. So if this is a proposition, then we can get the negation of it, which should still be a proposition, right? So if this is a proposition, then the negation of it is also a proposition. But what is the negation of it? The negation of this will be the sentence is false. This is the negation. They are negation of each other, right? So if the negation of this is not a proposition, then what does that mean? It means that this cannot be a proposition. So this is for one reason that we can see that this is not a proposition. But then this is not very convincing. This is not like an argument. It just says that okay, the negation of this is not, so it is not. Okay. But let's get a more direct proof why this is not a proposition. So what we are checking here is, so can this be a true proposition? Okay, so let's check. Okay. Now, if this is a true proposition, then what it is written is correct. So what is written is this sentence is true, and then we are really claiming that this is true, so everything is okay. So this sentence could be a true proposition, right? But how about this sentence? Could it be a false proposition? Could it be false? Now, if this sentence is a false thing, then what it is written is wrong. So the sentence is true is what it is written. If it is wrong, then we are saying that this sentence is false, should be the correct case. So if we start with the thing written on the board is wrong, then we will get the conclusion that the thing written on the board is wrong. So there is nothing wrong. There is no contradiction at all. There is nothing wrong. So again, after checking, we can still see that this sentence could be false. So what does that mean? So it means that this sentence could be true and could be false at the same time. So this makes it what? This makes it not a proposition, because proposition must be either true or false, but not both. So here it is both. Okay, I hope you understand this. Okay, so this one and the previous one are negation of each other. So we can see that this one, yeah, either both of them are propositions or both of them are not propositions. Okay, so next, let us talk about a logic puzzle that we have described in the video recording. So here we have a couple of kids. So let's say there are 20 of them. They are standing on the line. Okay, all arranged from tallest to the shortest. So all facing from left to right. So each of the kids is given a hat which is either black or white. So they can all be black, they can all be white. Some of them can be black, some of them can be white. We don't know. And then we want to play a game. So this game is having the rules as follows. So every one of them faces right. And then every one of them will make a guess of the color of his or her hat. And then we start from the leftmost. So this one is going to make a guess first by saying the word black or white. And after that, this one is going to say the word black or white for his own hat or her own hat, and so on and so forth. And then every one of them can listen to the answers of the other people. So we want to find out, is there a way that we can guarantee all of them are correct. Okay, but we can allow one wrong answer. So we want to make sure that, let's say, when there are 20 people around, can we make 19 correct guesses? Now, so the first one cannot, so everyone can only see the heads of the other on the right, but the guy here cannot see anything of his own head or her own head or anything before it. So everyone faces right, so okay, they can see only. So I have make a wrong guess. So everyone faces right. So what they can see, I didn't tell. So they can see all the things on the right side. Now for the tallest guy. So this tallest guy cannot make a correct guess at all. There is no way for this one to guarantee a correct guess because no one is giving any information about the head. So in that case, this one at most can make a blind guess at all. But how about the others? Is it possible that we can make as many correct guesses as possible? So one way to do so is, so I hope you may have already thought about this, but one easy way to get this, or a very clever way to get this, is the last guy is going to sacrifice, let's say this is a boy, sacrifice himself by telling the others, all the other people, how many black hats that he can see in total. But of course, he cannot do the communication by saying the number because he can only say black or white. So instead of telling the correct number of black hats, what he can do here is that he will see the number of black hats and then tell the others whether the number of black hats is an odd number or an even number. So for instance, this one, he sees in the front there are 13 black hats and then 6 of them are white. Okay, so this is an odd number. So he will use one of the answers. So let's say black for odd, W for even. So to tell the others that, oh, the total number of black hats that he sees is an odd number. By doing so, the one in front of him can make use of this odd number information to deduce correctly what is the color of his hat. And then once this is a correct answer, then the one that is in front of him can make sure that he is giving a correct answer, so he can also deduce what is the color of his own hat, and so on and so forth. So in the end, only the last guy cannot tell a correct answer, but all the people in front of him will be making a correct guesses one by one. So this is the answer of this logic puzzle. So this is related to a well-known technique in computer science for doing data checking. So this is called a parity check. So to use a certain extra value, we call it an extra bit, to tell the total sum of the original correct number of bits of 1, whether it is an even number or an odd number. This is used when we want to send information through the network which may be having errors, so that we will have an extra information to double check whether what we send is correct or wrong. Okay, so this is the puzzle that I want to give the answer today, but then I have another one for you that I won't tell you the answers now. Okay, so there's another one. Now in this another logic puzzle, we just have 2 people, and then each of them is given a black hat or a white hat. And then the rules are very simple. So each one of them can see each other. But then after seeing each other, they cannot do any communication. They just see each other. Okay. So they see the other's hat, okay, as well. And after that, each one of them is going to a separate room. And then in a separate room, there is no communication at all. And then they need to start guessing the color of his own hat or her own hat. And the question here is, can we guarantee at least one correct answer? So we don't need both of them to be correct, but need one, at least one. Now, if you can solve this, so normally, after thinking for a while, let's say at let's say half an hour maybe, you should be able to get the answer of this question. Yeah, just try. Yeah, try all the possible. So these two guys, they can do some agreement beforehand. So for instance, when I see your head, then what should I guess? Something like this. So you can, I'm pretty sure that you can get the correct answer for this case very quickly in at most half an hour, probably 5 minutes. Okay. But now, if you can solve this case, let's move on to a more complicated case. So this time we have three guys. So let's say they are all boys. Okay. Three guys. And then the same setting. So this time each one is having a hat, and then the color could be red, yellow, or green. So each one has a hat, and then red, yellow, or green. The rules are the same. Okay, so each one of them can see each other, and afterwards, each one of them is going to a separate room, and they need to guess the color of his hat. And again, this time, we just need to guarantee at least one correct. We don't need all of them to be correct. We don't need two of them to be correct. We just need at least one to be correct. So how can this be done? Now, this is like a much more complicated case. So if you can solve this, then this is really good. And once you can solve this, yeah, let's also try to make it even more complicated. Let's say there are 7 people around, and then each one has the hat, one of the colors of the rainbow. Okay, so one of the 7 colors of the rainbow. So in the same case, so we have the same rule. Each one of them sees each other. Can they have a way to guarantee at least one of the hats is guessed correctly? Okay, so this is the logic puzzle that I want to introduce. Okay. Okay, so because it is of the first week and then we don't have much to talk about, so let's end the class here. Okay, so thank you very much for coming, and then Happy Moon Festival. And one final thing. Okay, so this course we will have altogether a 3 hour lectures every week. So roughly speaking, what we are going to do here is that for every week, yeah, we expect you to see roughly 3 hours of OCW recording. So I will have time uh, to list out what exactly we are expecting you to see. But then if you don't receive any messages from us, then you can go ahead and then look for take a look of the next and the next OCW recording. Okay, so that's all. Okay, and then yeah, and then let's meet again on Wednesday for the class summary. So if you have any questions, please ask me now, or you can send us your questions through the questionnaires. Okay, the Google form. Okay, that's all. Bye bye. Bye. Thanks. Thanks for coming. Bye. Yeah, hope you like that. Yeah, hope you like the puzzles. Bye. Thank you for coming. Thanks. Thanks. Okay. Okay, so I will also log off now. So let me see.